Alrighty guys, this next lesson here, it says it right there, simplify the rational expression. So this is kind of putting all the little pieces together, because I did give you guys the very first, practice we did with stuff like problem number 7 and problem number 8, where it's just monomial stuff. And if it's monomial stuff, numbers reduce numbers, letters reduce letters, that kind of thing. So we've talked about that kind of stuff. And then I have two X'd out problems, number 10 and number 18, because I am not going to be tricky on this test. If I ask you to simplify something, it's going to simplify. Problem number 10, you can't simplify it. And problem number 18, you can't simplify it. So I skipped those. I'm like, why would I give you something like that? Anyway, I do want you to know that I gave you guys a lot of practice doing what I consider the Algebra 1 version of this stuff. So like where is it? Number 14. See number 14? You guys did a lot of this stuff in your summer packet, because this is something I knew I had to build off of. So the top part of that fraction there, I can factor it, and I can say x times x, that's my x squared. And then it ends with a -2, so I know it's, plus 1 minus 2, or it's minus 1 plus 2. It's one of those two patterns. I know it is. But the bottom part, hey, we just talked about that in the last lesson. That's the difference of two squares. So I could factor that thing and say it's x plus 1, x minus 1. And then I could go, hey, these two guys match exactly, and they can cancel. See, here's the part where we're going to pick up how to reduce binomial information. Problem number 7, problem number 8, that's reducing monomial information. But what do we do about binomial information? So here we go. Let me show you everything, and then we're going to walk through some examples. But I got to tell you, number 14, I'm not going to spend a lot of time going through the ones that I think are easier. I want to go to the ones that I want to get you guys some practice in. So 7 through 20 you can visibly see there, but what you cannot see is 21 to 30. And these ones are multiplication or division. So 21 to 30, it says perform the multiplication or division and simplify. So here's the deal with this. This is the same rule they taught you in the 5th grade. There's a dog barking outside. Same rule they taught you in the 5th grade. In the 5th grade, they said, hey, guess what? There's things out there called fractions, and you can simplify them. When it's something like 4/6, you just go, oh, I can reduce. 2 goes into that twice. 2 goes into that 3 times. That's called simplifying. Then they stepped up the game, and they said, hey, we're going to show you this trick where you can do a fraction times another fraction. And then they showed you this trick, hey, you can either multiply stuff together and then simplify it, or sometimes you can do this, like, hey, 4 goes into itself once, 4 goes into that 4 times. And if I want, I can continue reducing. I could say something like, I could do 6 and 10. What do they have in common? Or I could even do 4 and 10. 2 goes into that 5 times. 2 goes into that twice. And then I get to the end where I just 1 times 5 on the top, that's a 5. 6 times 2 on the bottom, that's a 12. So when they say perform the multiplication or division and simplify, it's the same trick they showed you in the 5th grade. You can cross-cancel things, or you can top to bottom cancel things. You just cannot sideways cancel things, because when you go sideways, that's when you're actually multiplying. And remember, division, if they stick a division symbol in there, they just mean take the second fraction, flip it, and make it a multiply. So what I want to focus on in my examples for this section are the ones that I did not put on your summer packet. The ones that you're going to see in your future, and intermingled in this practice sheet, you're going to see some of these tricks. So, the answer key for all the stuff I want you to do is right here. I had to do it in two pieces because I wanted to make it big enough to make it easily visible. But you'll see I crossed out the ones I don't want you to do. And then the ones that I do want you to do, you can trace. They factored it. They showed all their steps. The very last thing they wrote, well, guess what? That's the answer. The very last thing they wrote is the answer. So follow it down. Do remember stuff like this, 9/2 x squared. I could write that as 9x squared over 2. Same answer. Same answer. So here we go. Here's the other answers. But I highlighted 3 of these here and I said bad technique. Hey, this answer technically for number 23, it's right, but it's impolite. Number 24, it's correct, but it's also impolite. I will explain that when I go through my examples so that you don't make the same mistakes they did. So, anyway, here we go. Those are my answers for the other ones. You can pause it, take a picture of it. Let's talk about this example because I have I have lots of examples, but the very first one just reminds you that this stuff that you're seeing in the beginning of this practice is monomial information. On this first example, there are no plus or minus signs between the terms. So this is just good old-fashioned, hey, 3 goes into 6 twice. I get a 1 left over. There's only a negative in the top, so I can't cancel negatives. Hey, I'm more powerful than you, so I'm going to keep it, etc., etc. So this first one, you could technically say negative 1x over 2y squared. Oh, what did I write? I said squared and I wrote 9. 2y squared. So there's my negative. There's my 1/2. 1/2. The x, this guy was more powerful by 1. And then this guy was more powerful than the other guy by 2. Now, technically, you don't have to write all the ones. You could have just written your answer like this. You totally could, that's right. But what I'm trying to get at is, that's monomial stuff. But now we're going to spice it up. We're going to put some spice in it, but I didn't spice it up tons. I want you guys to understand that this whole thing that we're doing with simplifying, it all has to do with what we call factor and cancel. Now, I wanted to put this up at the top next to the questions, so I'm going to do this again. Okay? I am going to go up here. I want to get rid of this just for a second. Well, doesn't matter. You're going to do the work or show the work. But to simplify a rational expression, the first step is factor anything that you can. Factor if possible. That's the first step. Not everything factors, like question 7 and 8 there that you can visibly see. You can't factor anything there. But if you can, you're supposed to factor. Then the second thing is you cancel. You factor stuff, you cancel stuff. But do it do it correctly. And here's the best advice I can give you. Start with the basics. Start with numbers. Numbers will reduce numbers, okay? Numbers reduce numbers. When we teach you a technique in math, it doesn't change. So when you're reducing a fraction, it's the same rule it was in the 4th grade. Numbers reduce numbers. Then, we already talked about exponent rules. So when it comes to letters, like single letters in the problem, letters will cancel other letters. And what are we doing with that? We're doing the quotient rule, so whoever's more powerful gets to keep it. And let me get this other stuff out of the way here. And then binomials. Here's the part that messes a lot of people up. Binomials will cancel other binomials. They will. But only if they match exactly. And then this is a rare thing that happens, but it does happen. Trinomials can also cancel trinomials. It can happen, but they have to match exactly. So when you're going to simplify a rational expression, you want to factor everything that you possibly can, even if the factoring is just a GCF. Then you look to see, can I cancel anything? So I designed my examples to illustrate all these points. And you will see that some of the problems that they give you here are pretty straightforward, where you don't have to do a lot of factoring. But you want to make sure you don't break the rules for canceling. And then, of course, if you factor and cancel, whatever's left over is your answer. So let me go back now. I'm going to go back to my examples. And see, I wanted to make up this one where it's just monomial junk. But then I threw this, look, I even used the exact same stuff here. But I threw a trinomial in and I threw a binomial in. So my brain is telling me, I got to factor this stuff. So I am going to take this and I'm going to use a different color. And I'm going to bust this part up first. And I'm going to say, you know what? That's a trinomial. Trinomials, I can break up x times x. And then I go, what? Is it 1 times 6 or is it 3 times 2? Well, 1 times 6, 3 times 2. It looks like if I use a minus 3 and a plus 2, then I'm going to get a negative x in the middle, and that's what I want. And then I look down below here and I go, you know what? I don't have to worry, is it 4 times 1 or 2 times 2? I notice that guy. I recognize that guy is the difference of 2 squares. So I just say x plus 2, x minus 2. So let me just go through this with you. This is where I'm going to use a blue color. What the heck? I am blue color, not red again. Blue. Here we go. My rules for cleaning this up are the same as they were before. Numbers reduce numbers. So this first part up here, I'm going to get the negative 1 that I got in the first answer. I'm going to get a 2 in the bottom. But I'm just going to keep track of what stays around. So once again, this guy's more important than that guy. So the top's going to keep one of these. Hey, I'm bigger than you are, so I'm going to keep this. So I'm looking just like this answer here right now. But wait, there's more. See, here's what we're going to do now. Let's make this I did number cancels number. I did letter cancels letter. Binomial cancels binomial. I get left with this guy in the top and this guy in the bottom. Now just pause on that for a second. That's your answer now. Do not try to make up your own rules for canceling. Because you go, whoa, well that x, I could take that x with that x. No, you can't. X minus 3 is part of a binomial. X minus 2 is part of a different binomial. If they don't match exactly, oops, no, that's not what I want. I want to undo that. Here. If they don't match exactly, you don't get to do anything with that. That's your answer. Done deal. Now, like I said, some of the problems you're going to go through will have GCFs in them. Some won't. Some will factor and cancel right off. Let's just take a look at the different ways they could mess with us. So, this next example. Come on. There we go. This next example, it looks kind of ominous. It looks kind of scary. But there's definitely one thing I do not want you to do. It's called making up your own rules. Do not do this for me. Somebody always does this, and I go, why did you do this? I mentioned this in the video specifically. Do not do this, but somebody does it. And then I got to just take all the points on the test. I go, ow. Don't do this. This is a don't. Ready? Hey, x third knocks out x third. Ooh, 2 goes into 4. That's twice. Oh, I forgot about this fourth. 2 goes into that. That would make this x squared because he's more powerful. He keep. Oh, this goes. Oh, 10 knocks out 10. Don't do that. That is called making up your own rules. Don't do that. What's the first rule? If you can factor it, you factor it. So I'm going to get rid of all this junk I just did. I'm going to move all this goop out of the way. And let's look at what you do, not what you don't. I'm going to just look at the top because in the top I see a beautiful juicy GCF. I see that 2 goes into both of them. And x third goes into both of them. Remember, the greatest common factor is always made up of the smallest stuff in the problem. It's weird that way, but that's true. So, 2 goes into both guys. X cubed is part of both. So now I rebuild it, and I say, what would I need? Hey, 2x cubed times x would give me 2x fourth. Plus, I believe that I need a 5 here, and that'll make it work out. That's what I think is true. I cannot do anything more to the top part of that problem. But I can continue to work on the bottom. So let's look at what the bottom looks like. Now, I see in the bottom I also have a GCF. And you might go, no, 4 doesn't go into it. You said the greatest common factor is always based on the smallest thing. Or something that's small enough to go into the smallest thing. What goes into 4? 2. Does 2 go into the rest of them? Yeah. So when you're thinking greatest common factor, don't ever look at the biggest number and go, oh, 18 is the greatest. Yeah, but it's not common. So in the number 4, I know 2 goes into it. Also, I see all these guys have a variable, but I pick on the teeniest, tiniest of them. The greatest common factor is going to be based on that. So what could I do? I could pull out a 2x. But now I have a trinomial. So I'm going to do a step right below this so that you see it perfectly. What would I have to multiply my 2x by to get back 4x cubed? Well, it would have to be a 2x squared. Then, what would I have to multiply 2x by to get 18x squared? I'd have to multiply it by a 9x. And then 2x times minus 5, that'll give me back 10x. Now, this is something that people hate. They hate when they have to factor when there's a number here like a 2. Some people lose their mind when they see this. But let me show you something that is a total hint and a total good thing to look for on your practice problems. They want you to try to do your best to factor things and cancel things. So they are going to make stuff drop out. And as you practice, if you do this, it's going to make your work easier and you're going to start to notice patterns a lot quicker in your future stuff. So here we go. I took out a 2x. I know I'm going to put it over here. But I'm going to tell you, this part right here is going to break up. It's going to. And it's a trinomial, so it's going to break up into 2 binomials. To get 2x squared, it's got to be 2x times x. It's got to be. But the last sign here, this thing is a negative 5. The only way I get a negative 5 is if this is a plus and this is a minus. Or, let's back that up. What if this is minus and this is a plus? Either, if I multiply a negative times a positive, I will get a negative 5. I'll get a negative 5. So I'm going to put the 5 here, and I'm going to work backwards, put a 1 there. That's what I'm going to do. Why am I doing that? Well, I know that the only way I'm going to reduce this is if I can find a match for this in the bottom. And the only way I can find a match, see, I'm kind of being like a math detective here. I'm working backwards, letting the problem kind of whisper to me and tell me some stuff to try. Now look, I can check it. Negative 1 times positive 5 is indeed going to give me this piece of the puzzle back. And 2x times x is definitely going to give me this piece of the puzzle back. The only thing I have to verify is, does that, negative 1x, and then on the outside, excuse me, 2x times 5, that's 10x. Man, that's 9x's. That is totally the way this factors. Right? It's like totally, that's totally the guy. Safe driver, save 40%. Yeah, safe driver, save 40%. Okay, here we go. Ready? No one misses the big stuff. I see the big stuff from a mile away. Nobody misses the fact that, man, I can totally see those binomials match. Where do people mess up when they do this? They forget the little tiny stuff. So I always tell people, when you're trying to simplify, start with the tiniest stuff. 2 goes into 2. Those are gone. I am more powerful than you are. What's going to remain in the top then? X squared. What's left in the bottom? Well, this guy was bigger than that guy. Don't accidentally write him. Cross stuff out when you go through it to know what you're doing. But here's the bottom part, 2x minus 1. Boom. Now that is your answer. That's your final answer. But I want to let you guys in on something that you totally already know, but it prevents people from making errors. I don't want you to accidentally think that you can, come back to this and then do this with that. You can't. I'm going to undo that. You cannot do that. But if I put this bottom part in parentheses and I leave those parentheses there, it's still the same answer. I didn't change it. But what that might help you see is that the bottom part, that is clearly a binomial. This is clearly a monomial. Monomials do not try to pick on binomials. They don't. Monomials only mess with other single stuff. Binomials only mess with binomials, and that's if they match exactly. This is your final answer. You're done. I don't care if some people are like, I don't want to put the parentheses. Okay, fine, don't. Just don't accidentally go back to your answer when you're double checking your work and then knock something out that doesn't need to be knocked out. Be careful. Just be cautious. You don't get any extra points on a test for being the fastest kid done. You don't. So here we go. Let's look at the next one. Here's my next example. This one is a crucial example because in the book, in the answer key that I just showed you, there are 3 problems that I'm like, bad technique. And here's why it's bad technique. This is backwards. That thing is backwards. The letter should come before the number. So here is something that I did not put in my little simplifying rational expressions thing, but here is what you should always look for. When you're going to start, so before you start. Look, I'm using like fresh little quick ways to say English things. before you start, you want to check, is your problem in the correct order? Because if it isn't, you should start by rewriting it in the correct order. Then the second thing you should always look for is the highest power negative? Now, when I say highest power, I don't mean x cubed in the bottom there. No, no, no. You have to read the numerator separate from the denominator. So when I say is the highest power negative, in the numerator, look at the numerator. It says this. And I would say unto you, the highest powered thing is negative. So what do? I take it out like a -1. I treat it like a GCF. This will now be rewritten with the negative out front, and I will put this in its place. Just imbibe that. Drink that in. Take that step in. It's super crucial. The top part of this problem should have been written like this all along. This is somebody trying to mess with your mind at the beginning. But you don't have to fall for that. Before you start, you get it in the correct order. You make sure the highest powered thing is not negative. You take it out like a GCF. Look, see, that's like a -1. I just treated it like it was a GCF. But that will go a long distance. So now I'm going to look at the denominator. Let's look at the denominator. Is it in the correct order? Cha. Is the highest powered thing negative? No. So I should have started this problem making it look like that. That should have been my very first step all along. And then, this is a formula, and so is this one. Don't you dare start making up your own rules going, hey, 4 goes into 8, x squared goes... Don't you dare. No! Don't make up your own rules in math. Let's take the top part, because see, I like to do the easiest part of a problem first. So the top part to me is easy, because I look at that and I go, that's difference of squares. X plus 2, x minus 2. The difference of two things that are squared. But in the bottom, I have the difference of cubes. So I look at this thing and I go, oh, wait a minute, that's cube formula. So I have to put that into this guy. And that was what we did for our last little video. So here we go. Let's dink around. What's it going to look like? Well, I'm going to finish it off here. Instead of a minus b, I'm going to do x minus 2. Instead of a squared, I'm doing x squared. Instead of x2, I say 2x. And instead of b squared, I say 4. And I know to stop, because the last lesson we had was using the cube formula to break things up. And I know for sure this part right here never factors. So when I see that it's got cube formula in it, I know I'm going to have a big chunky trinomial that won't break. So I don't want to waste my time. This part won't factor. So what do? Well, I'm going to use red pen. I'm going to go, this guy matches with this guy exactly. And that is all I can do. So I get a negative. I get an x plus 2. And on the bottom, I got this big old chunky monkey. And you know what? I'm going to leave everything in parentheses because I want to make sure I remember the top part is a binomial. The bottom part is a trinomial. There is nothing more I can do. And then somebody always does this to me. They go, well, why didn't you just do this in the bottom? And I say, because it's not true. Because it is not true. Check it. You can check this so quick. X times x, that's x squared. 2 times 2, that's 4. Oh, maybe you're right. No, because look, that's 2x. That's 2x. That's 4x. That is not a 4x in the middle. This is not 4x. Don't try to factor this. This part right here won't factor. It won't factor ever, so just leave it alone. So let's go back. Going to make this look prettier. Going to just remind you, come on, right here, that was our final answer. How did this question begin? It actually began right there. But I wanted to make sure before you start, you got to remember correct order, highest power negative, you treat it like a GCF, you get it so that it is startable. I don't know if the word startable is a real word, but get it startable first. And then be on the lookout for things like cubes. Be on the lookout for that. All right, we're almost there because that was a big pointer outer of information. Let's go here. This is now multiplying. We're going to multiply this. Now, multiply, don't let it freak you out. You have 4 pieces. You have 2 numerators and 2 denominators. But let's follow what I just told you. One of these 4 chunks is in the wrong order. And if you see that it's in the wrong order, don't copy it down in the wrong order. Save yourself a step. This is how it looks in the book. This is how this problem is printed. But I would look at it and say, shenanigans. This guy right here is backwards. That guy is bad news. It should say this. It should say negative 2x plus 10. Because letters are cooler than single numbers. So let me just do this. To save a little bit of space here, I'm going to get rid of this guy, and I'm going to put this dude in its place. Because if I were to copy this out of the book, that would be the way I would have copied it to begin with. So I'm going to move that out of my face, and let's begin. Since I just messed with that, I know that it's in the right order. And now I look at it and I say, the highest powered thing technically looks like it's negative. So I'm going to take out a negative, but I can also take out a 2 because remember, that's a GCF. If I take out negative 2, I will get x minus 5. Double check me, but I believe I am correct in that statement. So this part right here has been factored. What I like to do when it's a big multiply problem like this is I work above and I work below the question. I do. It just makes it easier on my brain. So I go like this. I go, hey, I already factored you. I'm done. Now look at below it. Look right below it. Do you guys see this part here has a GCF in it too? It does. What is the greatest common factor? X. So I am going to take that piece and I'm going to pull the x out. And then I go, wait, what would I need back? I'd need x plus 8. I have factored this piece of the puzzle. But guess what? I don't see anything that can cancel yet, but I'm not done. I'm going to move back now. And since I'm like, this dude is just bugging me because I know it's difference of squares. I am not going to mess around a moment more. I am going to write it out and say x plus 5, x minus 5. You have been factored. Now, let's look. We got one last piece of the puzzle that we haven't messed with, and it does look kind of spooky, but it's not that bad. I can take out a GCF. What does this whole big chunky monkey have? It has an x. And then I could say x squared plus 6x minus 16. And then I look at this trinomial and I go, okay, trinomial, if you are going to break up, I'm going to look right here. This guy's a little hint. Because 16 Could be 4 times 4, or it could be 8 times 2. And if it's 8 times 2, then I got a match in the bottom. So I'm going to be so bold as to say this. X minus 2, x plus 8. I am going to use the problem to help me see what might be there. Because x times x, that's x squared. Negative 2 times positive 8, that's negative 16. And then negative 2x's plus 8x's is 6x. That's how it breaks. That's the guy. Safe drivers say 40%. So I'm going to take that and put my little GCF out in front and realize I have factored all of this stuff. So where is my collection going to take place? Let's use green. What the heck? I am not going to make a mistake with the big stuff. I've already warned you about this. Big stuff is really easy to see. It's the tiniest pieces that get lost. Okay, it's the tiniest chunks that get lost. So, I did this backwards in my brain. I always start with numbers. So I go, are there any numbers, single numbers? Yes, negative 2 is one of my single numbers. Gotcha. This x would cancel this x. There are no x's left. Then I would have done the binomial stuff, because really, binomials are easy to spot. It's the little guys. So what survived in the top? Well, it looks like I forgot this piece. And in the bottom, it looks like I have this piece. And I am going to leave that in parentheses because I can see that this binomial clearly does not match this binomial. It does not. And if I leave it alone right now, it's right. It's a correct answer. But if I take away the parentheses, is it still correct? So I want to warn you, when you check your answer with any book, any answer key, sometimes they'll write the answer a little bit differently, and you might go, wait a minute, how come I didn't get this answer? So, for example, just on this one, and then we only have one more example. Negative 2 x minus 2 over x plus 5 is the exact same answer. It totally counts as correct. It does. But if I took the parentheses away here and just wrote it like this on the top, it would be incorrect. Because if I have parentheses there, that would mean negative 2 times both of these. So if you wrote your answer like this, technically it would also be correct. It would. But I'm going to give you a word to the wise. Word to the wise. Once you break it down into its simplest parts, that is the most appropriate and useful way to represent your question. This over here is technically correct. I wouldn't mark you wrong, but I would say when you get to calculus, you might want to rethink it and leave it in its broken down components like I did over here. Okay? So, let's get Christmassy. You know, hey. Some red and some green. That would be my preferred way to write the answer. Okay? That would be the best. This is still correct, but this guy over here is better. Oh my god, that's the worst star. Ah, that one's horrible too. Okay, I'm going to stop trying to draw stars. Okay, here's my last example, and it's a division problem. Okay? So here's the thing. You guys know that in a division question, you leave this fraction alone. Don't touch it. Don't touch. But what do? You take this one over here and you reverse it. So guys, if you see on the original problem that it is a division question, please do not write it down as a division question. That's busy work to write it down and then recopy it like a multiply. See, look at what I did there, huh? I just pre-flipped it. Copy it down like a multiply. I know the question was a division, but your first step is to do this. Now, this is the thing that most people mess up because they get freaked out when they see there's more than one letter. Multiple letters do not make the problem more difficult. Get it out of your head. Don't get intimidated. But also, don't think that any of this stuff is going to be monomial. Look, this top part here, that's a trinomial. Do you see a GCF in that? Do you see that all of them have an X? Oh, no, they don't. Do all of them have a Y? No. There's no GCF. Okay, well then what do I do? You don't panic. That's what you do. Check this out. If I want to factor this thing, this is actually a pretty easy thing to factor. If I want to get x squared, I have to do x times x. That's how I get x squared. You know what? How do I get y squared out of that? Well, it would have to be a y times a y. I want it to be positive, and I want this part to be positive, so I'm going to put a plus in both of these. And guess what? You can double check me, but that's how it factors. It is certainly how that this thing right here done been factored. Now you might go, oh, okay. Yeah, but what about this one? There's a 2 here now. Do you see a GCF in all this junk? I don't. So don't cry. Don't panic. How do you get a 2x squared? Well, one of them has to be a 2x and one has to be an x. That's 2x squared. Oh, y squared. I need a y and another y. I want it to be positive and I want this to be positive. So put a plus, put a plus. Look, I can show it works. If I did 2x times x, I'd get 2x squared. If I did this times this, I'd get 2xy. Right here, I'd get xy. Wait a minute, 2xy and another xy, that's 3xy. Oh my gosh, it does factor that way. Let me get all that jazz out of the way. A lot of jazz going to get, oop, there we go. So don't panic. When you see double letters, don't freak out. Now, I got the first 2 things factored, and I can already see that I have a match binomial in the top and bottom, but there's still more to the problem. But don't start thinking these are monomials. I got a GCF in the top. It's a 7. If I take it out, I get x squared minus y squared. I do. That's difference of squares. That is one squared thing. Take away another squared thing. Don't panic. You know this. You got this. There's a 7 out front, and then this would be x plus y, x minus y. Bam. I've factored you up. And in the bottom, what's the GCF? I think it's a big old juicy 14. And then I got x plus y. Did I break everything down? I certainly did. Even though there's multiple letters in it, do not stray from what you're naturally going to do for a problem like this. Now, I'm going to do this the way I like to do it. I look for the smallest stuff first. There is a 7 in the top. There is a 14 in the bottom. Well, what about this 2? That's part of a binomial. Don't you dare touch it. Oh, okay. 7 goes into 14 twice. Who's going to keep it? The bottom. The bottom has a 2 in it. Okay, I don't see any single letters. There doesn't have to be. Sometimes there isn't any. But I do see this. I have one of these takes out only one of these. One of these takes out one of these. Now, I could go over here and get rid of this one if I want. As long as they match, I can do it. Okay? As long as they match, I can do it. But I don't get to go, oh, well, that one also looks like that. Let's get rid of him. No. It's a 1-for-1 relationship when you cancel. You don't get to do a 2-for-1 special or anything like that. So what's left over in the top? Well, it looks like an x plus y, and it looks like an x minus y. Those are the things that are left over in the top. What else is left over in the bottom? There's one thing. It's right here. And do any of those binomials match exactly? The answer is heck no. That's my final answer. And we are done. I have no more examples for you. And I know this is a long day because it's a lot of video. But it's super important video also. Okay, so let's go back. I'm going to scroll up to the very top, and I'm going to remind you. The first two problems are monomials, don't require factoring. Don't get faked out. You see number 9? You can pull a y out of the bottom. There's a GCF in the bottom. There's a y in the bottom. Skip the ones that are X'd out because they don't cancel. I don't know why they would give you practice for simplifying and then it doesn't even simplify, so skip it. Then 21 to 30, you can see that those are mostly written as multiply problems. But there's a couple divisions, and I'm not going to point this out on every single problem for you. I am not, but I'm going to just say be on the lookout for stuff that's in the wrong order that has a negative that can come out, because I did give you guys hints about that. Here's your answer key, and look, see, bad technique. Look, they have a backwards piece of info in their answer. That's a better answer. Okay, they have backwards info. Oops, I wrote over the other one. Let me undo that. See, because I like this answer right here. It's more polite. I like this answer right here. It's more polite. So sometimes the person who's doing the math, and then look, this guy eventually at the end wrote it politely, but he did this mess up in the middle. What? What is that? So be careful for bad technique on some of this. Okay, but there's your answer key for all that. You can pause everything. You can take pictures of everything. Okay, guys, that's a big day. Let's call it quits. Bye-bye.